Let f of t equal 2t minus 22, and consider the two area functions. A of x is equal to the integral from 11 to x of f of t dt, and f of x is equal to the integral from 14 to x of f of t dt. Evaluate a of 12, a of 13, and use geometry to find an expression for a of x for all x greater than or equal to 11. Evaluate f of 15, f of 16, and use geometry to find an expression for all f of x with x greater than or equal to 14, and show that a of x minus f of x is a constant, and that a prime of x is equal to f prime of x is equal to f of x. And I've got a graph here of the function f of t. You can see that it crosses at t equals 11. It's a linear graph, so it has a slope of 2 and a y-intercept of negative 22. Okay, so let's begin. The first thing that we want to do is find a of 12 and a of 13. Okay, so given that we have this right here, we know that a of, well, let me just write a of x is equal to the integral from 11 to x of f of t dt, which means a of 12, let me give myself a little room here, is equal to the integral from 11 to 12 of f of t dt, which is the integral from 11 to 12 of 2t minus 22 dt. Okay, so you can figure this one out with geometry if you want. If you look at the function there, we're basically, when you're finding the integral from 11 to 12, you're finding the area under the curve of this. So it's just a triangle here, right? So if we go from 11 to 12 and we figure out the height of this triangle here, we know from 11 to 12 the base is going to be 1 unit long, and the height is going to be whatever the value of plugging in t equals 12 into f of t gives you. Okay, so that's one way of doing it. We're going to do it with regular integration rules. Okay, so I'm just going to take the antiderivative of 2t minus 22. Okay, so that's going to be equal to t squared minus 22t, and I'm going to evaluate from 11 to 12. Okay, so that's going to give me 12 squared minus 22 times 12 minus 11 squared minus 22 times 11. Okay, and if you plug that in to your calculator, you're going to get 1 is the answer. Okay, so this one turns out to be 144 minus 264 minus 121 minus 242, and you do all that and you get 1, which is the same answer that you would get with geometry if you did it that way. Okay, so if we plugged in a 12 into the function, into the original a of t function, you plug in a 12 right here, and you get 24 minus 22, which is 2. So the height of that triangle that we were looking at on that graph, the height is 2, the length is 1. So the area of that triangle is base times height divided by 2. 2 times 1 divided by 2 is equal to 1. So it works with geometry or with regular integration rules. All right, so let's do it again for a of, what were we asked? 13. So that's equal to the integral from 11 to 13 of 2t minus 22 dt, which gives us t squared minus 22t evaluated from 11 to 13. Okay, so do just what we did last time. So it's going to be 13 squared minus 22 times 13 minus 11 squared minus 22 times 11. Okay, so if you figured this one out on your own last time, which ended up being, this inner parentheses ended up being negative 121, but with the negative, this whole thing here with the negative turned out to be positive 121. That's a little shortcut you can use. Okay, but if you put that in your calculator, you should get negative 117 for this, and then minus negative 121 for that. And if you put that together, you get 4, because negative and negative make positive, so you get 4. Again, you can figure that out using geometry if you want. I'm not going to go through that again, but you could. All right, So the last question on A was find an expression for a of x. Okay, so in order to find an expression for a of x, we need to look at the graph again and start where the integral started. So a of x, remember, a of x says it starts at 11 and goes to x. Okay, so in our graph, we know from last time that it crosses the t-axis there at 11. Okay, so we're going to plug in an x to make that an x-axis, but it still crosses at 11. Okay, so what we're interested in this graph is that it starts here at 11 and it goes somewhere out to some value of x. What value of x? That doesn't really matter because we're finding an expression that's going to work regardless of where the x is. Okay, so you can see this is a triangle. So what we're going to be doing is trying to find this, so a of x. Okay, so how do we go about doing that? Well, we use the fact that the figure here is a triangle, which is base times height divided by 2. That's the area of a triangle. Okay, so the base is going to be this distance here. That's b. The height is going to be this distance here. That's h. Okay, so to figure out b, what is that distance b? Well, that's going to be x minus 11. Okay, so distance between 2 points on a line is the bigger one minus the smaller one, so x minus 11. Okay, what is the height of this thing? Well, we need to plug in x into the function f of t. So remember, f of t was equal to 2t minus 22. So if we plug in an f of x, it's simply 2x minus 22. Okay, so that's the height. Remember, we're not getting an actual number here because we're just plugging in an x, not a number. Okay, so we have the base, we have the height, and we're going to divide that by 2. So a of x is equal to base times height, so x minus 11 times 2x minus 22 divided by 2. Okay, notice that this 2x minus 22 can have a 2 factored out of it. So if I put that, first of all, if I take the 2 out, it will become x minus 11 because I divide both of these terms by 2. And when I take the 2 out front, it reduces with this 2 on the bottom. So this ends up being x minus 11 times x minus 11. And if we multiply that all out, we will get x squared minus 22x plus 121. And that is our representation for a of x. Okay, that's it for A. Let's move on to B. Okay, so B is going to be very similar to A. Notice that it says f of x is equal to, the only difference here, we're starting, whoop, you can't see. The only difference here is that it starts from 14 instead of 11. Okay, so if it's starting from 14, remember our graph here, 14 is going to be over here somewhere. Okay, and if this was our x, which we'll use later, notice the difference when we're finding the area function. It's no longer going to be a triangle like this one was. This area function is going to be a trapezoid. So that's going to be the main difference in this problem. Okay, so let's begin. So the first thing we want to do is evaluate f of 15 and f of 16. Okay, so f of 15 is equal to the integral from 14 to 15 of f of t dt, which is the integral from 14 to 15 of 2t minus 22 dt. So all this is very similar to what we just did. The only difference is the lower limit is different. Okay, so we already know that that becomes t squared minus 22t, and we're going to evaluate that from 14 to 15, which means we have 15 squared minus 22 times 15 minus 14 squared minus 22 times 14. Okay, and if you plug that in and work that all out, you're going to get that this is negative 105 minus negative 112, which is 7. And again, you could figure that out also using geometry. The difference is that it would be a trapezoid, which we'll talk about that in a second because we're going to have to use that. But it is a little more difficult to find the area of a trapezoid than a triangle, but not much once you know the formula. Okay, and now for f of 16. Okay, so f of 16, going from 14 to 16 this time, of 2t minus 22 dt, which is t squared minus 22t from 14 to 16, which means we get 16 squared minus 22 times 16 minus 14 squared minus 22 times 14. Okay, and if you work all that out, you are going to get 16 as an answer. I'll let you plug that into your calculator yourself. Okay, so f of 16 is equal to 16. Okay, so the last thing that we want to do on this problem is figure out what the formula is for f of x. Okay, so we're going to do this the same way we did our last one. So we need to graph it first. I already did this earlier, but let me do it again. So at 14, we're not touching the t-axis like we were before. We're up here at 6, I believe. I'll plug that in and confirm in a second. So we've got, this is where the graph starts, and then we go to some x value out here. We don't know what that x value is, but it's going to be up here because this is a linear function. So this, the line keeps going down. Well, actually it would go down. The angle's wrong, but it doesn't matter. So this is a trapezoid is what we're looking at. Okay, so the area of a trapezoid, write that down, is equal to 1/2 times h times b1 plus b2. Didn't realize I was running into a line there. So it's 1/2 h b1 plus b2. Okay, so what is b1? What is b2? Okay, so the b1 and b2 are these lines right here. So we need to know, I'll just call this one b1, this one b2. H is here. So we need to know this distance here, which is going to be x minus 14. We did that earlier. To find these, we plug it into the function. So I need to plug in a 14 into the function f of t, and I need to plug in an x into the function f of t. So f of 14 will give me that height. You remember the f of t is 2t minus 22. So 2 times 14 minus 22. So again, just recall, we're plugging into this function right here. It's plugging in a 14 right here to get the height of b1. Okay, so that's going to be 28 minus 22, which is 6. That's what I thought it was. Okay, so this is 6. And then to plug in f of x to get b sub 2, it's just 2x minus 22. Okay, and the height, we already said, h is equal to x minus 14. So if we plug all that into this formula for the trapezoid, we get 1/2 times x minus 14 times, so that's this one, b1, which was 6, plus b2, which is 2x minus 22. Okay, so 1/2, here's h, here's b1, the height of the function at 14, here's b2, the height of the function at x. So we just need to clean this up. 1/2 times x minus 14. Let's see, if we do this, we get 2x minus 16. Okay, let me factor out a 2 out of here, which would make this x minus 8. When we factor the 2 out here, it cancels with the 1/2. So it becomes x minus 14 and x minus 8. And if you work that all out, you will get x squared minus 22x plus 112. Okay, so that is the function f of x, capital F of x. Okay, almost done. Letter C is pretty quick and easy. It says, letter C says to show that a of x minus f of x is a constant. So that's pretty easy. All we need to do is plug in a of x, subtract f of x, and see if we get just a constant. Okay, so recall that a of x was equal to x squared minus 22x plus 121, and f of x was equal to, we just wrote that down, x squared minus 22x plus 112. Now you can already probably see that if we subtract these two functions, this is going to cancel, this is going to cancel, and there's going to be left a constant. So you can already see that it's true. Okay, but let's go ahead and write it out. So x squared minus 22x plus 121 minus x squared minus 22x plus 112. Okay, so when we distribute the minus, it becomes negative x squared, positive 22x, and negative 112 in this parentheses if we're adding it. Okay, so the x squareds cancel. The negative 22x cancels with the positive 22x. And then we have a 121 minus 112 equals 9. Is 9 a constant? Yes. So it is a constant. Okay, and then the other thing it said is to show that a prime of x equals f prime of x equals f of x. Okay, so that's pretty easy as well. We have a of x. Let's just take the derivative. So a prime of x is equal to 2x minus 22. F prime of x is equal to 2x minus 22. Just taking the derivative of these functions. And then recall that f of t is equal to 2t minus 22, so that if we plug in an x instead of a t, that's going to be 2x minus 22. Are all these the same? Yes, they are. So you have confirmed that they are equal. And that's it.